All right, welcome to section 1.6. We are talking about parent functions. Nothing today but functions. And what we're going to do is basically go back and we're going to talk about domain and range and increasing and decreasing for all of these specific parent functions. And parent functions, as you look at this, is just the most basic graph. This is just the most basic graph of each type. For example, constants and identities and lines and parabolas and all of that kind of stuff. We are only talking about the most basic, and then we'll apply what we know from there as we go through. And so we're going to start with the constant function. The one thing you should be able to do is not use your calculator for this section. So try to not use your calculator. The biggest thing in pre-calc, and we start in chapter 3 where we do not use calculators for half of the stuff anymore, and so please try and get out of using your calculator. And so I want to look at this. If this says f of x equals 3, f of x is really the same thing as y. And so if I'm trying not to use my calculator, I'm going to make a table. If this says every y is 3, every y is 3, then I'm going to just pick a couple of points. And if every y is 3, x can be whatever I want it to be. And so I'm just going to pick the easiest ones I can, 1, 2, and 3. Now I'm going to plot these points, 1, 3, 2, 3, 3, 3. And you'll start to notice that they're all at the same level, and this ends up being a horizontal line. Okay, so a constant function is really just a horizontal line. Now, as we look at this, I'm sorry, that should actually fill in this blank. As we look at this horizontal line, we want to talk about domain and range. Well, basically, if every y is 3, I can input any number I want. I picked my numbers. So if I can input any number I want, then I'm going to go from negative infinity to infinity, okay, any number. Because it needs to be an interval notation, don't forget that infinities need parentheses. The range, what do the y values have to be? Well, every y value has to be 3. And because 3 is the only number we have, and we want to include it, 3 is included, I'm going to use a bracket. Okay, so again, our goal is to try and get away from using the calculators. And we want to really do a lot of discussion in class as to why this works. The second graph is called an identity function. Okay, the identity function is basically the most basic form of a line. Okay, and so as we look at this, let's make a table. Because again, I'm going to try and not use my calculator. And I'm going to pick any x's. I'm going to say negative 1, 0, 1. And you want to pick like 2 or 3, it doesn't matter. Well, if x is negative 1, this basically says to me y is the same thing as x, so y would have to be negative 1. And if x is 0, then y is 0. And if x is 1, then y is 1. So I plot these points, 0, 0, 1, 1, negative 1, negative 1, and I end up getting this line. Okay. What's special about this line is it's a line through the origin. And that's why it's the most basic type of line, because there is no y-intercept. It goes right through that origin. Now let's talk again about domain. Did I have any restrictions on this x value? No, I just picked whichever ones I want. And because I was able to pick, I could pick any number from negative infinity to infinity. I mean, if I wanted, I could have said 542 or negative 10,000. It wouldn't have mattered. And if I put in any number, I got out the same number. So my range is from negative infinity to infinity as well. Now let's look at our line. What's the slope? What is the rise over run? As I look at this, from one point to the next, I go up 1 over 1. And then I could go up 1 over 1, and up 1 over 1. And so my slope is 1. And we already talked about the fact that it goes through the origin, so the y-intercept occurs at the point. I'm going to put points in there so I remember 0, 0. Okay? As I look at my function, and you talk about increasing and decreasing as you look from left to right. So as I go from left to right, it is always increasing. And I normally like trace it to kind of look. It's always increasing. So as I go up from left to right, if it's always increasing, then we say from negative infinity to infinity. That basically means always. Where is it decreasing? Well, if it's always increasing, then it's never decreasing. And so I would just say none. Okay? There is no interval in which this function would be decreasing. Let's move on. Let me get rid of this and slide myself down. The third function we're looking at is absolute value. Okay? An absolute value by definition means it's a distance, and distances are always positive. So as I go to make my table, we can pick some x values. How about negative 1, 0, 1, and 2? We'll go a little farther. Well, if I put negative 1 into my function, the absolute value of negative 1 turns it positive, it gets you 1. The absolute value of 0 is 0. The absolute value of 1 is 1. And the absolute value of 2 is 2. And so I'm going to plot these points. 0, 0, 1, 1, 2, 2, negative 1, 1. If I kept the pattern going, at negative 2 I get 2, at negative 3 I get 3. And what you end up finding is that you get what we normally say is a V-shaped graph. Okay, V-shaped graph. Now, what values did we pick for x? Any ones we wanted. So my domain is from negative infinity to infinity. The question though is range. What type of values did we get out? Well, we got out positive values, right? These are all positive values, but we also got out 0. And so 0 is the smallest number we got. So we say 0 to infinity. It goes up from there. Infinity always gets a parentheses. But since we actually have a point at 0, we need a bracket to say 0 is included. As I look at intercepts, where does it touch the x-axis? It touches at the point 0, 0. And we again like your intercepts or your zeros to be points. Where is this function increasing? Well, if I look at it, it starts at 0 and it increases as I go, as I go to the right. And so 0 to infinity. And again, increasing and decreasing, don't forget, these always have parentheses. Where is decreasing? As I start to the left and then move my way to 0. And the way we say that is from negative infinity to 0. And again, we don't include the endpoints because functions don't increase or decrease at endpoints. They increase or decrease between the endpoints. The final function on this side is the squaring function. You guys know it as a basic quadratic. Let me use better words. So you're used to seeing this as a basic quadratic. And again, if I can do this without my calculator, I'm going to be better off in pre-calc. Let's do negative 2, negative 1, 0, 1, and 2. And what happens when you square a negative is it turns to positive 4. Squaring negative 1 turns to a positive 1. Squaring 0 is 0. Squaring 1 is 1. And squaring 2 is 4. And you'll notice this has some symmetry. So let me plot some points. Negative 2, 4. Negative 1, 1. 0, 0. 1, 1. 2, 4. And you'll kind of see the shape. This is a parabola. Let's talk about domain. We again picked any x's we want, so my domain goes from negative infinity to infinity. My range, you'll notice I don't have anything down here. And so again, like the absolute value, I start at 0, and everything then is above the x-axis from there. So from 0 to infinity, and it includes 0 because there is a point at 0. The next question is not in the one above, but is this an even or an odd function? And we talked in section 1.2 that and 1.4 that even functions are symmetric with the y-axis, and odd functions are symmetric around the origin. And so as I look at this, you can see the reflection from here to here. It's reflecting over the y-axis, therefore this is an even function. The only intercept I have is at the point 0, 0. It's increasing and decreasing just like the absolute value function. It increases from 0 to the right, so from 0 to infinity. It's decreasing from the left down to 0, so from negative infinity to 0. Make sure that negative's clear. And because it's an even function, it's symmetric with the y-axis. Okay, so we've done the first 4 functions. We're going to give you another 4 to look at, and they're going to get a little bit more difficult as we go through. But this is the idea of why we use interval notation. It works so much better than writing it out. We talk about intercepts and even and odd, and we're doing all of this over and over and over again. So let me slide to the next page. Let's do a couple more. Let me move this up a little. We're talking about a cubic function. Let's again pick some numbers. -2, -1, 0, 1, and 2. I'm going to start at 0. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. -1 cubed is -1 times -1 times -1, which is just -1. And -2 cubed is -2 times -2 times -2, which is -8. So let's plot these points. I've got 0, 0, 1, 1, 2, 2, 8, and then -1, -1, and -2, -8. And you'll notice it's kind of a skinny little S-shaped. In your description, what shape? The reason we ask you this is basically so that you can describe this once you see a cubic. You know, anything cubed, you should kind of know its shape. And so a lot of people describe this as S-shaped. And I don't know if you can kind of see it. It's or squiggled, I've heard, anything like that to make sure you know what it looks like. We again picked our x values, so our domain is from negative infinity to infinity. You'll notice our range, we have negatives, you know, we have positives, we hit 0. Because we hit all 3, our range is from negative infinity to infinity. Is this even or odd? Well, if I look at this graph, I can't reflect it over that y-axis, but I can rotate it around the origin. Therefore, this is an odd function. And I'm going to come down here too and say it's symmetric to the origin. Because you'll notice if I take that and reflect it or rotate it around the origin, I would get the same graph again. The intercept, the only place it touches the x-axis is at the point 0, 0. It's increasing. Let's trace it from left to right. As I trace it from the left, it's increasing, increasing, increasing. It's always increasing. So always we said was negative infinity to infinity. And I'm just going to put always there so you remember that. When is it decreasing? I'm going to say none. It never does anything like that as we go through. Now again, you could use your graphing calculator to draw these graphs, but trust me, you're going to be so much better off by not. Okay, square root function. Let's make a table again. -2, -1, 0, 1, and 2. Let me start at 0. The square root of 0 is 0. The square root of 1 is 1. The square root of 2, I don't know that well, so I'm just going to leave it as the square root of 2. But 4 I know, the square root of 4 is 2. And I know I jumped there, but I wanted to get us another nice value. What about the square root of a negative number? The biggest thing is you cannot graph the square root of a negative number. So this, neither of these work. And you would get an error in your calculator. And this is going to help us with domain and range. So let's graph the points at least that we can. 0, 0, 1, 1. What's another nice one? 2, 3, 4, 2. And you'll notice it kind of has a shape like this. Now, how do you want to describe it? A lot of people have said like half of a sideways parabola. And that seems to be the most heard description for what a square root function looks like. Now, as we do domain, we picked any value, but did all of them work? Well, no, they only worked from 0 down. And so our domain is going to be from 0 to infinity, and 0 worked. 0 gave us an answer, so I'm going to put a bracket. Now, if I look at the values I got values like 0, 1, 2, square root of 2. They're all positive. And I'm never going to get a negative number out of this, so my range ends up being the same thing, from 0 to infinity. 0 is included, again, because I can square root 0 and still get 0. The only intercept I have is the point 0, 0. Okay, as we look at this, where is it increasing or decreasing? Well, again, the easiest way, in my opinion, is to trace from the leftmost part of your graph, trace right, and you'll notice this will always increase. And it looks like it levels off, but it's not a big enough picture. It doesn't end up leveling off. So it increases from 0 to infinity because I don't have any x values that are on this left-hand side. I don't have anything there, so I've got to start at an x value of 0. As I traced from left to right, did I ever get decreasing? We didn't, so I'm going to say none again. Okay, so we're through 6 of the graphs, and I hope by this point in time you're starting to see the idea of domain and range and where intercepts are and increasing and decreasing. We're going to do the last 2. And then if you have questions or concerns, anything like that, we'll talk about them in class tomorrow. Get rid of this stuff. A reciprocal function is 1 over x. I'm again going to try and make a table. If I can, again, I'm trying to use everything I can without my calculator. Some of them we will, and that's fine. Let's do a couple of values. I mean, it's kind of up to you which values you pick. But how about, let's just go with our standard, -2, -1, 0, 1, and 2. Okay? If I take 1 divided by -2, I end up getting -1/2. 1 divided by -1 is just -1. 1 divided by 0, anything divided by 0 is undefined. Okay, anything divided by 0 is undefined. 1 divided by 1 is 1. 1 divided by 2 is 1/2. Okay, so I'm going to plot these points and we're going to kind of see what shape we kind of end up seeing. At -2, I have -1/2. At -1, I have -1. And then it seems to skip. At 1, I have 1. And at 2, I have 1/2. And we said at 0, we were undefined. This undefined means I have an asymptote, and so I'm going to draw this asymptote in as a dotted line, And that means my graph should not touch that asymptote, okay? And so what ends up happening, and I'm going to draw this graph for you, and then we're going to talk about it a little bit more. It won't touch this line, but let's talk about why it won't touch this line either. It will never touch the x-axis, because in order for a fraction to be 0, you'd have to divide 0 by something in order to get 0. And if 1 is on top, I'm never going to be able to get 0 as an answer, and that's why I can't touch this x-axis. So this ends up being two different asymptotes, the x-asymptote and a y-asymptote. The shape of this graph is what we call a hyperbola. Okay, and we studied this in Algebra 2, and we're going to come back and kind of look at some of the basics of it. As you look at domain, the x values, we put in a lot of x values, and the only problem we had was at 0. Because the 0 kind of splits up this whole interval for x, we have to look at domain in two different ways. We have a domain that goes from negative infinity to 0, but it doesn't include it. And we have an interval that goes from 0 to infinity. And the reason we have to split them up is because we can't just break an interval. And I use these parentheses again to say 0 is not included, because if I include 0, that's where I have this asymptote right here. Okay? And you'll notice the range does that same thing. To account for this asymptote here, we have to say from negative infinity to 0 and from 0 to infinity. Now your textbook throws in this U in between it. That U just means and. That's all that this means, is just and. So I'm saying I have this interval and this interval. Okay? Is this an even or an odd? Well, I can't take this graph and reflect it over here, but I could rotate it around. So this is an odd graph, which means it's symmetric to the origin. Do I have any x-intercepts? The answer is none, because it never touches this axis. Where is it increasing? Okay, well, let's travel from left to right. Here's my leftmost part. As I travel here, I'm decreasing. Okay, so let me put that in interval notation. From negative infinity to 0, not including. And let's do the next part. As I travel from this leftmost part of the branch down, I'm still decreasing. So I'm going to put that union from 0 to infinity. What that means is I'm never increasing. Okay, the final function that we have is called a step function. We also call this a rounding down. And basically what a rounding down function means is that every decimal you have rounds down, no matter where it's at, rounds down to the integer right below it. Negatives still round down, you get -8. And the only way it jumps to the next integer is if you actually hit the next number. So it wouldn't touch 24 here until I actually had 24 point something. And that's when you'd see it hit 24. Now we show you how to put it in your calculator. Please make sure you can do so. The biggest thing though is that some of the calculators don't pick up their pencils, and so it'll look in calculators like this, and that's not the case. It is only this portion, and it's only this portion, and it's only this portion, and only this portion. And so please be careful. Some of the 83s don't actually break up a pencil or stop graphing. They just connect them. The step function ends up looking like this. At 0, I get the point 0, and I will get it until I hit 1. And at 1, I'll get the point 1. And at 2, I'll get the point 2. And at 3, I'll get the point 3. And I will have those points until I get there to the next spot. And so it ends up looking like this, and I want to draw it for you over here. It's a closed circle with a line and then an open circle, because I jump then to the next value of a closed circle and then an open circle. And I can't have two closed circles here, because if I had two closed circles, it wouldn't be a function. And so that's what ends up happening on this graph, and I apologize, my pen's not doing a very good job of showing that. This is called a step function, and it just basically looks like a bunch of steps. The domain, I can put in any number I want. Any decimal, any fraction, zeros, positive, negatives, it doesn't necessarily matter. It's the range that is the issue, and the only values I get for the range are those whole numbers, positive and negative. And the way we say whole numbers that are positive and negative is we say integers, and there is no way in interval notation to actually be able to write that, and so all I need you to say is integers. Okay, before tomorrow, please make sure that you can get this step function into your calculator, and that if you have any questions that you discuss them with us tomorrow in class. So thank you for going through the functions with us. Again, please circle, star things, highlight things as you're going through that you didn't maybe understand so that we can discuss them in class.